I'm going to continue to work through the problems that I haven't solved yet. Just to see if that's something that students would benefit from. So I did the middle column, so I'll start with number one. Number one, I'm going to start by dividing by 5. It's going to give me y minus 3 is equal to, and then 19 divided by 5. 15 divided by 5 is 3, and that would be 4 over 5, so 0.8. When I add 3 to that, I get y equals 6.8. I did number 2 in class. Number 3, when I subtract 8, I get the absolute value of 4x minus 7 is equal to negative 2. And you can't have absolute value equal to a negative. So there's no solution. That one was easy. Great. Number 4. So this is a quadratic. Oh, I forgot. This one is linear. So we just get, right, it's not x, but you get one solution. And then number 3 was absolute value. So the number 4 is quadratic, so has the exponent of 2. We want to get 2 answers. When I look to factor this, because that's my first method, I get 10 and 14. So that's 1 and 14, 2 and 7, not going to work. So I'm going to use the quadratic formula or completing the square. Since this is even, I'll go ahead and complete the square. I move the old c. And then I've got x squared plus 10x plus something is equal to negative 14 to get these out of the way. And that will be plus that same thing. So I'm going to just make those blanks there. I know that I want it to be x plus half of 10, 5 squared. And so I think, okay, the fill in the blank would be 5 times 5, because remember it's x plus 5 times x plus 5. So I know 5 plus 5 is 10, 5 times 5 is 25. So 25 minus 14 is 11. When I take the square root to get rid of this exponent of 2, I get x plus 5 is equal to plus and minus the square root of 11. Finally, I'll subtract 5, getting my answer as x is equal to negative 5 plus or minus rad 11. That's actually 2 answers, because I could write that as negative 5 plus rad 11, and then I could write negative 5 minus rad 11. I did number 5 in class. I did the middle column. So then here I am looking at number 6, and I see that the highest exponent is 1. So 6 is also linear. Combining my like terms on both sides of the equal sign is helpful for me. So I'm going to simplify on each side first. That would be negative 2m minus 10. This would be, that's negative 3 positive 1, negative 2m minus 10. Oh, well, this is a funny one. So we have the exact same thing on both sides. So that's infinitely many solutions. Or you could say all real numbers. If you didn't notice that, you would keep going and you would say plus 2m plus 2m. They both cancel out. So you get negative 10 equals negative 10. And that's a true statement. That's why that's the case. Let's look at number 7. Giving me this back. I need to see the signs there. So seeing again, the exponents are 1, and I'm not going to be multiplying them. This is again linear. This is a linear proportion. And so what I do on these problems is I multiply the entire thing by the GCF. So that's 21. And so that 21 goes to both parts. So the 21 here and the 21 still right here. So the 21 divided by 3 just gives me 7 times x, which is 7x. And then the 21 and the 7 here cancel, so I have 3. And then I put the parentheses so I remember to distribute. I'm distributing here instead of dividing so that I don't have a fraction until the last step. So then I have 7x is equal to 3x plus 15. Subtracting the 3x gives me 4x equals 15. So then I divide by 4 to get x is equal to 15 over 4. Cool. I did number 8 in class. Number 9 is awesome. I did number 9 in 5th period. So I noticed that it's 5 and 5. So I begin by an equation dividing both sides of the equal sign by 5. What that's going to do is divide both of these. Another way you could have done it is take the 5 and then make it x to the third minus 1 is equal to 0 and then divide it by 5. But the result is x to the third minus 1 is equal to 0. So this is a polynomial. And I am going to get 1, 2, 3 x's because the degree is 3. And so I would just get 1 if I used cube roots. I would add 1 and take the cube root, but I'm going to factor this. This is that special happy face factoring. And so I get x minus 1, same sign, and then I get x squared. Then I get plus 1x, and then I get plus 1. So this one gives me the answer 1. 1 minus 1 is 0. And then this one I use the quadratic formula. So that's going to be negative 1 plus or minus the square root of 1 minus 1 times 4. I'm sorry, minus 4 times 1 times 1, which is just 1 minus 4, all divided by 2a, which is just 1 times 2. Oh, I wrote 1 again. I need to write 2. So we could see in the radical here, we're going to get negative 3. And that just means that's going to become I rad 3. So I have negative 1 plus or minus I rad 3 over 2, which to write that as 2 answers, negative 1 plus I rad 3 over 2 and negative 1 minus I rad 3 over 2. Very fun. Those ones are tricky. The hint, though, is that you always get I rad 3 for those cube binomials. Okay, looking here at number 10, this is a polynomial. And then I see the highest exponent is 3. So again, we're going to get 3x values. And since it is a true four-term polynomial, I start by drawing the fence. Taking out the x squared, I have 5x plus 2. And then I see that it leads with a negative, so I take out a negative 1, and I get 5x plus 2 again. So then it's x squared minus 1, which I see that, and as I'm writing it down, I know that factors further. That's that special difference of 2 squares. So that's going to be x plus 1, x minus 1, and still 5x plus 2 is equal to 0. So if I set each one of these equal to 0, I end up with my answers, but these ones are easy. Negative 1 here, positive 1 here. And then this one, I'll show my work with this equal sign. So I add minus 2, and then I divide by 5. So it's negative 2 over 5. Very cool, thanks. All right, number 12 is linear exponent of 1. And I'm just going to go with this one. So when I subtract 4, I've got 4 is negative. So I've got m divided by 8 is equal to, and then I'm just going to rewrite this as not negative 4, but negative 16 over 4. which is the same as -4, right? I times the top and bottom by 4. That will give me -13 over 4. And then I see that it's m divided by 8. So to get rid of division, I multiply by 8. Just timesing this by 8 over 1 on this other side to show how I do that work. I'm going to cancel and have a 2 here, because that's easier for me. And then I get m is equal to -26. Cool. 13 is another polynomial of degree 3. So 1, 2, 3 x's. And I notice the GCF, so I take that out right away. And I notice that it leads with a negative, so I'm going to take out a negative x. That's going to give me 8x squared, switching the sign, so plus 13x, switching the sign, -6 equals 0. This is one of the factors, and if I had -x equals 0, x would be 0. So that's my first solution. So then looking at this problem here, I've got -48 and 13. It's a quadratic. I want to try factoring it, and it does factor 16 minus 3. So 8x squared plus 16x minus 3x minus 6. And then I draw the fence, and I take out 8x, x plus 2. This is a negative, so I'm going to take out a -3. X. Let's see. The computer screen doesn't exactly do what I think it will do. X, and I switch the sign on the 6, so plus 2. And that gives me 8x minus 3, and then x minus, x plus 2. I'm already trying to think of that next step. So that tells me why sometimes we switch the sign by accident. So then this one would be -2 plus 2 is 0. And then on this one, I'm going to show the work all the way over here. I add 3, cancels out, and then I divide by 8. So the fraction is 3 in the numerator, 8 in the denominator. Just always like to show my work on those so I don't accidentally write it as 8 over 3. Okay, cool. 15 is absolute value. And we expect 2 answers for this, unless, like we saw, there was no solution. So here I isolate the absolute value to start. So I divide both sides by -2. And that gives me the absolute value of 3x minus 2 is equal to +8. So this will yield 2 results. 3x minus 2 is equal to 8. Or there was another possibility that the entire absolute value inside here was -8, which evaluates to +8. So 3x minus 2 equals -8. The work is the same on both of these. I add 2. Which sometimes I like to do it like this, where I do it all together. And then I've got 3x is equal to 10. 3x is equal to -6. Dividing both sides by 3. I get +10 over 3 as one answer. And then that 6 and 3 will reduce to -2 as my other answer. All right, moving right along, hopefully. Yep. Okay, number 16. This is a quadratic. I'm going to look to factor this. 21. Did I already do this problem? So that's 7 and 3. Oh, yay, 7 and 3 add to 10. So x squared plus 7x plus 3x plus 21 equals 0. So this is one that has that lead coefficient of 1. So I can actually skip all of these steps only when it has that x squared. So that's going to be x times x plus 7. And then I have plus 3 times x plus 7, giving me x plus 3 times x plus 7 is equal to 0, which is x is equal to -3 and also -7. Cool. I don't think I got to 17 in most of my classes, but I'm not doing the middle this time. All right, 18 is linear. Instead of distributing, what I'm going to do is get rid of that 1/4. The reciprocal is what I use with fractions, so I do times by 4/1. That gives me b minus 16 is equal to 28, and then I add 16. Then I have b is equal to, that would be 14. I get 44. Wonderful. 19 is another quadratic. So this one has a lead term of 6, or a lead coefficient of 6. So I've got 66 and 4, and it's a positive 66. So there's no way that's going to work. So I have to use the quadratic formula here. I'm expecting 2 answers. They might both be imaginary. Probably. All right, so I've got -4 plus or minus b squared, which is 16, minus 4 times 6 times 11, all divided by 2a. So a is 6, so 12. All right. So I see this and I'm like, oh, great. 16 minus 66 times 4. Oh, all right. 6 times 4 is 24. Carry the 2. It's not so bad. 6 times 4 is 24. Plus 2 is 26. So these have opposite signs. I see that the 264 is bigger than the 16 and the 264 is negative. So I know that I'm going to get an imaginary solution here because there's going to be a negative in the radical. So borrowing from the 6, I get 5. 14 minus, well, so these are opposite signs, so I subtract. That's why I'm showing this subtraction. 14 minus 6 is 8. 5 minus 1 is 4. So it's negative 248. Well, 48 sounds like it's divisible by 4. Might be divisible by 16, but I'm not sure. So 4 goes in, well, negative 4. 4 goes into 24 6 times and into 8 twice. I know 62 is even, but I think it's just 31 times 2. So this is going to be it, which I'm happy about. Putting these back, they're in the radical. The square root of negative 4 is actually 2i. And then I have rad 62. So seeing the 4 and the 12 and the 2 out front, I am going to separate the 12. -4 plus or minus 2i rad 62, both over 12. Reducing those, I've got -2, and then this will just be gone. So it's all over 6, plus or minus, that would just be a 1. And then, so I would write I rad 62. And those are my 2 answers for X. Hey, I thought that one was going to be really hard, but the hardest part for me really was the multiplication. I don't do that very often anymore. All right, 21. Oh, another cubic binomial. This is a polynomial. And this is that special happy face factoring. So I take the cube root and I have x plus 5. And then I generate the trinomial as x squared minus 5x plus 25 equals 0. So my first answer here is that x is equal to -5. And then I'm going to get 2 more from the quadratic formula. So it'll be x is equal to +5 plus or minus 25 minus 4 times a times c, all divided by 2a. So this is 25 minus 100, which is -75, which is -25 times 3. And the square root of -25 is 5i. The rad 3 stays. So my answers are x is equal to 5 plus or minus 5i rad 3 over 2. And so again, we see that whenever we have this cubic binomial, we get I rad 3 in our answers. That's good. It's nice that some of the problems have hints. Not all of them do. Okay, solve and graph the inequality. All right. So I see that here's the positive x, so I'd like to keep that. I'm going to add 3x. And simultaneously, since I'm adding x to this right-hand side, I'm going to add 4. This cancels and this cancels. So one thing on each side cancels, which is nice. So I've got 2, inequality is the same. This is 4x. Dividing by 4, I get, and watch how I write this. I write x, the point is facing x. And then I get 1/2. So I like doing it where x is first because I like to read it this way. And this is clearly saying x is less than or equal to 1/2. So here's 1/2, right? And then it's a closed circle. And less than goes towards the negative numbers. Negative infinity, positive infinity. Great. 24. Same idea, but wow, this one is messy. Looking at this, I'm going to subtract 3 to begin, and then in that same step, distribute. So that's going to give me, let's see, 8a minus 20, 7a plus 12. So I see that there are more a's here on the left, so minus 7a. So if this is where the a's are going to be, I need to get rid of the 20. So that's a greater than or equal to 32. So this one again has a closed circle because of the underline. Negative infinity, positive infinity. Here's 32. And it's a closed circle, and greater than goes towards positive infinity. Beautiful. Okay. Find the x and y intercepts. Oh, I'd love to. So y-intercepts are easier. So I'll find those first. That's 0, comma for the y-intercept. And I would get 0 for y. So isolating the absolute value, I add 3. Oh, wow. And then I have 3 is equal to the absolute value of x plus 1. So I get the two answers. X plus 1 equals 3. X plus 1 equals -3. Subtracting 1 on both sides. Oh, I said I was doing the easier one and the hard one. I'm doing the work here where I replaced y with 0. So I have just found the x-intercepts, right? Great. Well, good. I got the hard thing out of the way. So here I got 3 minus 1, which is 2. And then here I got -3 minus -1, which is -4. Great. Let me find the y-intercept. That's when I plug in 0 for x. That's way easier. Look at how little work I have to show. 0 plus 1 is 1. The absolute value of 1 is 1. 1 is positive. 1 minus 3, -2. I told you that was easier. All right, cool. 27. So surprisingly, 27 is quadratic. Let me find the y-intercept first for real this time. So that's just going to be 0 for x. So that's 0 times 0 minus 4, which I can already tell is 0, because 0 times -4 is still 0. And then if the y value is 0, well, hey, let's be smart. X and y are 0. So that means the x-intercept is 0, 0, but it's a quadratic. So we expect 2. Since it's already factored, which is intercept form, we just set each factor to 0. x equals 0, x minus 4 equals 0. So we got that one already. So I have to add 4, and I get 4 comma 0 also. I almost forgot about the 4 comma 0 once I got that really fast, easy one. But remember, 2 x's being multiplied means there need to be 2 solutions. All right, 28. This quadratic is more obviously quadratic. So to find the y-intercept, remember this is standard form. So the y-intercept is 0 comma c, which is 0, -1. Yes, that makes me happy. And then the x-intercept is when I've got 0 equals 3x squared plus 6x minus 1, which is all the work we've just done like a 1,000 times. So when I look at this, 3 and -1, my AC would be -3. That's not going to add to 6. So I'm going to use the quadratic formula. X is equal to -6 plus or minus 36 minus 4 times 3 times -1, all divided by 2 times 3, which is 6. All right, so the side work in here is 36, and it's going to change because of the 2 negatives to plus. 4 times 3 is 12, which is 48, which is 16 times 3. And the reason that matters is because the square root of 16 is 4. Great. Looks like this is glitching a little bit. So I've got -6. Oh my gosh. Let's reopen this. Sure, we'll save it. Why am I saving it? I'm going to close the program. Okay, let's try it again. I'm just going to share my screen. And here it is. And look, I can annotate. I was on this problem 28. So cool. Looking at my annotations, that was -6, x is equal to, plus or minus the square root of 36 minus 4 times 3 times -1. Aha, yes, and then it was 6 here. Okay, so that was -6 plus or minus, this became the square root of 48, which was 16 times 3, which is 4 rad 3. Dividing both of these by 6 will help me reduce. Oh, no. So I wanted to say the same denominator. So I'm just going to divide them so that this will stay as 3. So look at that. This would be 2 and this would be 3. Whatever. X is equal to -1 plus or minus 2 rad 3 over 3. I'm fine with it. Okay. 30, another absolute value problem. I see this right away. I can see the vertex is 4, 2, and that it's facing up, right? Here's 4 for X, 2 for Y, right? And it's facing up. No X-intercepts. So let's find the Y-intercept, 0, comma. So that's 0, comma, 1/3. And then the absolute value of 0 minus 4 is -4, right? Plus 2. So the absolute value of that is +4. So that's going to be 4/3 plus 2. Or 4/3 is 1 1/3. So this would be plus 2 more 3 1/3. And then I know there will be no X-intercepts, but how do I know that mathematically with this equation without knowing how to graph it? Well, I replace the Y value with 0, get 1/3, x minus 4 plus 2. I subtract 2. I've got negative 2 is equal to 1/3 x minus 4. And then this is a fraction, so I use the reciprocal. I times by 3 on both sides of the equal sign. And I'm still negative, right? Oh, I forgot. This does not allow me to scroll. So then that's negative 6 is equal to the absolute value of x minus 4. And that's where we see, oh, the absolute value before I've done anything is negative. That's no solution. Cool. Let's move on to, who else do we need to do? 31. Well, 31 I can see as a quadratic equation. Again, it's in standard form. And I see the vertex at 2, -4, right? In my mind, that's what I'm seeing. It's 2, -4, right? Maybe here. And the a value is negative, so it's facing down. So there are going to be no x-intercepts. So whatever. So let's find the y-intercept. It's in vertex form, so I've replaced the x with 0, so that's -2. And then 0 minus 2 is -2. Squared is 4 minus 4. So this is y. And then that's going to be -8 minus 4, which altogether is -12. So we got 0, -12 as my y-intercept. Now, if I attempted to find the x-intercepts, I would add 4 because I replaced the y with 0. I've got 4 is equal to -2, x minus 2 squared. And then I would divide by -2. And I have -2 is equal to x minus 2 squared. And I would take the square root. And hopefully it's here that you find that an imaginary number would pop up. And that's how we know that there are no x-intercepts. Because x-intercepts are where it crosses the x-axis and they are never imaginary. Oops. There we go, 33. Oh, yay, a linear equation. So this is linear. And this is mx plus b, so here's the y-intercept. 0, -9. So fun. And then if I had 0 for y, I hope you can see we're going to add 9. And then we're going to divide by 3. And we get 9 divided by 3, x is equal to 3. And how nice, linear just has one of each. So we're really grateful for that. I know that there was a really weird problem on here for the x and y intercepts. It's like that cubic one. Let me see if I can find it. Here it was, 26. Okay, we're not going to make you solve for the the x-intercept in this form when it doesn't work out really nicely like this one did not. So if you were able to do that one and get the answer on the key, you are very special and talented. We'll do more work with that next semester. All right. Here we go. I'm on to 34 and oh, these are all just 2 and 2. All right. I'm just going to do the harder ones. So, or whatever, vertex form. So standard form just means I multiply this out with FOIL. That's going to be x squared minus 5x minus 1x plus 5. And that's x squared minus 6x plus 5. Here, I've got 2x plus 3 times x plus 3 minus 8. So this one is x squared plus 6x plus 9, doubling all of those numbers, 2x squared plus 12x. It's plus 18 minus 8, so plus 10. To write the equations in vertex form, I need to first find the vertex. And so I'm going to use negative b over 2a for this one. which is the formula for h. So that's going to be -4 over 2 times -3. Oh, thank you. That's 4 over 6, because they're both negative, which is 2/3. Ugh, okay. So whatever, I just need to plug that in as the x value. -3 times 2/3 squared. So squaring 2, I get 4. Squaring 3, I get 9. Plus 4 times 2/3 minus 1. All right, so the 3 over 1 and the 9, they're going to cancel, and I'm going to get -4 over 3 plus 2 times 4 is 8 over 3 minus, let's go ahead and change this to 3 over 3. The 1, right? So adding the numerators, I get -4 plus 8 is 4. 4 minus 3 is 1 over 3. So here's my h. This is the work to find k, the y value of the vertex. So knowing that it's y equals a, x minus h squared plus k, I write it as y equals -3. This is still the a value. And then it's x minus 2/3 squared plus 1/3. That was lovely. I thought that would be harder. All right, cool. Now this other problem I'm going to show a different way. I'm going to show this one in completing a square, because that's super fun and cool. So I want to write it like this. Too soon. So I've got x squared plus 16x plus something special plus 48. This is y equals. I'm leaving it in this form. So I'm going to add something here. So to make things balanced, I'm going to subtract that same thing here. And I'm looking at this and I know that right when I FOILed, I add the two things together. So what plus what is 16? It's going to be 8. So this is x plus 8 squared that I want. So 8 plus 8 is 16. That's good. So now I need 8 times 8, which is 64. That goes in both of these. So now I do the subtraction, 64 and 48. That's hard because that's subtraction. So this is going to be negative. Put the 48 here, and that's going to give me, why did I borrow and turn it into a 2? Let's see. I borrow and it turns to a 5. So 14 minus 8 is 6. 5 minus 4 is, oh, why didn't I didn't remember that. Okay, cool. And that's great. See, I like that way. It's really fun. It really shows the understanding of how this binomial squared works. So 8 plus 8 is 16, 8 times 8 is 64. So we always keep the same sign on the binomial. Very fun. Well, it's 8:45, so I'm stopping.